The star creepy crawly Juju, a red very immense monster found in the superb gathering of Orion, has long charmed stargazers and cosmologists, the equivalent in light of its sheer size and wonder. On the off chance that Betelgeuse were set where our Sun is, it would contact the circle of Jupiter, attesting its gigantic size. In scorn of being arranged around 642 light-years from Earth, its monstrous size makes it potentially quite possibly one of the most splendid stars evident to the undeveloped eye. Anyway, Betelgeuse has shown abnormal behavior, for instance, shocking clouding and enlightening cycles, which numerous experts believe signal that the star is approaching the finish of its life. The prestigious physicist Brian Cox recently offered a basic statement that Betelgeuse is on the edge of a faltering influence expected to occur within the next 14 days. This event, known as a huge blast, will mark the finish of Betelgeuse's life, but it will give a striking opportunity for examiners to focus on quite possibly one of the most shocking areas of strength in the universe. As a red very giant, creepy crawly is organized as one of the biggest and most colossal sorts of stars. It has been on the grandiose radar for quite a long time. However, its recent unusual differences in brightness have started theories that it is getting ready for an enormous blast. When a star like Betelgeuse reaches the finish of its life, its core falls under its own gravity, driving to a huge impact that releases a tremendous amount of energy, radiation, and galactic material into space. Betelgeuse's approaching effect is expected to be a Type II vast blast, a specific type of heavenly impact that happens when the center of a gigantic star collapses. This core breakdown triggers the release of neutrinos and radiation, creating a shock wave that annihilates the star. The impact will be so brilliant that it may be visible from Earth without telescopes, potentially even obscuring the moon in the night sky for weeks or months. While such an event wouldn't regularly be shocking if it happened near Earth, creepy crawly Juice's distance of around 642 light-years means that although the impact will be noticeable and emotional, it won't pose any danger to life on our planet. In any case, the event promises to reshape our understanding of vast blasts and other galactic phenomena. A grandiose blast is potentially one of the most powerful events in the universe, delivering more energy in a very short time than the Sun will radiate over its entire lifetime. Betelgeuse's impact will not just be an astonishing showcase but also a grand moment for science. Specialists are anxious to observe this spellbinding event from its earliest moments, utilizing an assortment of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much information as possible. At the point when Scarab Juju explodes, it will radiate an immense range of radiation, from visible light to gamma rays. Quite possibly one of the most vital pieces of the grandiose blast will be the flood of neutrinos, precarious subatomic particles that rarely interact with matter. Neutrinos from an enormous blast can actually reach Earth before the light from the impact due to their capacity to go through almost anything without being impacted. Observatories like Japan's Superkamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving an early advantage in tracking Scarab Juice's last moments. The impact will also provide fundamental insights into the creation of heavy elements. When stars detonate, they produce and dissipate elements like iron, gold, silver, and uranium, materials essential for life as we know it. Concentrating on Scarab Juice's astronomical blast will offer researchers a clearer understanding of this element creation process, which is fundamental for figuring out the development of planets and the science of the universe. While Insect Juice's enormous blast isn't expected to harmfully affect Earth, it will interact with our planet's climate and magnetic field in interesting ways. The energy burst from the blast, especially the release of gigantic beams and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these immense beams could impact satellite communications and some advances on Earth, the disturbances are expected to be minor and brief. Maybe one of the most thrilling aspects of Betelgeuse's blast is that it will be visible to everyone on Earth, not just professional cosmologists with advanced equipment. For months or even years, Insect Juju is expected to be the most brilliant object in the night sky, potentially even visible during the daytime. This exhibition will charm not just standard researchers but also amateur space experts and the general public, sparking renewed interest in space science and the universe. Researchers have long speculated about insect juices passing, but Brian Cox's recent statement adds significance. Observatories around the world are planning to monitor each phase of the enormous blast, and the data gathered will potentially change how we understand heavenly developments, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's enormous blast will allow specialists to refine their models of huge star behavior. Being relatively near Earth, it offers a remarkable opportunity to measure how energy from such an event moves through space by observing the light and radiation from the blast as it interacts with the interstellar medium, gas and dust between stars. Space experts will gain a clearer understanding of the size of the universe, and the event will offer a once-in-a-lifetime opportunity to investigate dark matter and how it could influence the structure of the universe. Dark matter, the mysterious substance that makes up around 85% of the universe's mass, doesn't radiate or absorb light, making it difficult to detect. However, seeing how light and matter behave around scarab Juju after its explosion could provide indirect insights into the role dark matter plays in the universe's large-scale structure. Betelgeuse's monumental blast will also bring us closer to understanding the life cycles of stars, especially how massive stars contribute to the production of the components necessary for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living things. By concentrating on insect juice, researchers will gain important insights into how these elements are made and distributed. The social significance of creepy crawly juice's blast is also notable. For centuries, people have looked to the stars for guidance, inspiration, and meaning. The vanishing of one of the most visible stars in the Orion constellation will ignite philosophical reflection on the transient nature of the universe. In some cultures, such heavenly events have been interpreted as omens or signs of significant change. Scarab Juice's blast might inspire a mix of awe, fear, and wonder as people from all backgrounds witness the death of a star. This fabulous event is likely to reignite interest in space exploration and stargazing, bringing more people into the quest for knowledge about the universe. Amateur cosmologists are already preparing for the event, as modern technology allows nearly anyone with a camera. Betelgeuse's impact is not just a grand cosmic event but also a stepping stone for future investigation. The data gathered from the infinite blast will inform how we study other stars, particularly as we venture further into space with missions to different planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity looks to expand its presence in the solar system and beyond. Additionally, the blast will reignite interest in the search for extraterrestrial life. Supernovae are fundamental for spreading the building blocks of life, such as carbon and oxygen, across the universe. By studying Betelgeuse's blast, researchers can better understand how life's building blocks could spread to other planetary systems, potentially starting life elsewhere in the universe. As insect juice's approaching blast looms, it stands as one of the most important cosmic events in recent memory. Its immense explosion will provide a wealth of scientific information, enhancing our understanding of the universe and undoubtedly captivating people around the world. Scarab Juice's demise will mark the end of a massive star, but it will also represent the ongoing cycle of creation. What's more, obliteration that oversees the universe reminds us that, from death, new stars, planets, and even life itself can emerge. As we plan for this memorable occasion, the world will enthusiastically watch the night sky, anticipating the moment when one of the universe's most powerful forces erupts into view. For both researchers and stargazers alike, Betelgeuse's final venture will be stupendous. As Betelgeuse approaches the last phase of its life, one of the more theoretical yet entrancing possibilities associated with its looming explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for the majority of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae, like the one anticipated from Betelgeuse, could hold the key to unlocking some of these secrets. Supernovae release tremendous amounts of energy and radiation. Some researchers believe these powerful forces may interact with dark matter in ways we can observe and study. One fascinating hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, Their interaction with the energy released by Betelgeuse's cosmic explosion could provide clues to their nature. Such a discovery would be pivotal, offering the first direct evidence of dark matter, a mysterious phenomenon that has baffled scientists for decades. Moreover, there is hope that Betelgeuse's explosion could offer insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. By studying how light and energy behave during Betelgeuse's cosmic blast, researchers could gather crucial data on how stellar events like these might interact with the fabric of spacetime itself. Although still speculative, this type of research could revolutionize our understanding of the fundamental forces shaping our universe. If Betelgeuse's massive explosion turns out to be a critical event for unraveling the mysteries of dark matter and dark energy, it will cement its place not just as a spectacle for astronomers, but as one of the most significant cosmic events in history. The stage is set for Betelgeuse's grand finale, bringing with it an exciting opportunity to unlock some of the most profound secrets of our universe. As scientists continue to monitor Betelgeuse's life, its inevitable explosion will serve as a turning point for cosmic research. The event is expected to spark a surge in funding and interest in astronomy and space exploration. Foundations worldwide are already preparing missions and research projects to study not only Betelgeuse but also other supernovae, black holes, and other massive phenomena. A deeper understanding of supernovae and their implications will have major ramifications for future space missions and humanity's comprehension of the universe. As new tools such as the James Webb Space Telescope, JWST, come online, the ability to observe distant supernovae in extraordinary detail will expand our knowledge of stellar death. The JWST, with its infrared capabilities, will enable astronomers to observe the earliest stages of cosmic explosion impacts and the material they eject into space. These observations will provide us with insights into the formation of stars, the evolution of galaxies, and the distribution of heavy elements across the universe. This event also holds broader implications for the search for extraterrestrial life. The explosion of massive stars like Betelgeuse presents an opportunity to study the conditions necessary for life's building blocks to spread across galaxies. Supernovae are known to produce elements essential for life, including carbon, oxygen, and nitrogen. The debris from Betelgeuse's explosion could even contribute to the formation of new planets and stars in the surrounding interstellar space. As these elements disperse, they create the conditions for life to form in other corners of the universe, raising questions about the possibility of life beyond Earth. The explosion will also underscore the significance of vast distances and the time it takes for information to reach us. The light and radiation from Betelgeuse's cosmic explosion will take 642 years to reach Earth, highlighting the immense scale of the universe and how much is yet to be discovered. As we witness this event, it will remind us of both the insignificance and importance of human existence in the grand expanse of the cosmos. This realization may foster a deeper appreciation for space exploration and the need to protect our planet. Culturally, Betelgeuse's impending explosion has the potential to leave a lasting legacy. As the cosmic blast unfolds, it will become a shared experience for humanity, sparking curiosity, wonder, and philosophical reflection. People from all walks of life will gather to witness the event, whether through telescopes, online platforms, or simply by gazing at the night sky. The event will undoubtedly inspire future generations of scientists, engineers, and visionaries eager to explore the mysteries of the universe. In the long run, Betelgeuse's massive explosion might even influence how humanity approaches space exploration. As we move closer to launching missions to Mars and beyond, the need for advanced space technologies and a deeper understanding of stellar phenomena will be more pressing than ever. As Betelgeuse approaches its cosmic explosion, its imminent demise becomes a moment of immense scientific significance. The event will offer researchers a once-in-a-lifetime chance to gather new insights into stellar life cycles and supernova mechanics. While scientists have long studied these phenomena in distant galaxies, Betelgeuse's proximity makes it a unique opportunity to observe every aspect of the supernova in greater detail. The data obtained will be crucial for improving models of stellar evolution, particularly how massive stars evolve into red supergiants and eventually explode. Another exciting aspect of the explosion is how it could contribute to the understanding of neutrinos. These elusive particles, which interact weakly with matter, could provide a unique view of the events unfolding within the star. Researchers are particularly eager to study how neutrinos from Betelgeuse could arrive before the light, offering a new way to detect the origins of a supernova. This could allow them to observe a supernova before it becomes visible to the naked eye, providing an entirely new perspective on stellar explosions. Beyond physics, Betelgeuse's explosion is expected to spark interest in our place in the universe. People may begin to ask deeper questions about the fate of other stars and how many more stellar phenomena like Betelgeuse's demise will unfold in the future. It could inspire a renewed sense of exploration, with increased interest in celestial bodies far beyond the reach of current technology. This may also motivate educational programs aimed at reaching younger generations, encouraging them to pursue careers in astronomy and space science. Additionally, Betelgeuse's explosion could have cultural implications. As one of the most recognizable stars in the sky, its disappearance may hold symbolic significance for many people around the world. It may inspire reflection on mortality and the transient nature of life, not just on a cosmic scale but also on a personal level. In this way, the death of Betelgeuse could unite humanity, reminding us of our shared existence one day.